All right, guys. So today we're going to start our study of the unit circle. The unit circle is the basis of all trigonometry that you will be working on for the next couple years and even in college. So we want to make sure that you get a really good foundation on it. These are the way your notes look. This part is not on the piece of paper that I gave you. It's just on your notes packet, but it's all going to be repetition where we're going to just kind of keep doing it over and over until we really understand it well. We start off with our understanding of a 45, 45, 90 triangle. Remember how the ratio of those sides is always 1, 1, radical 2. But when we were talking in the warm-ups, remember how I told you that we actually want this radius, if that's going to be the radius of a circle, we want that radius to be 1. So what am I going to divide radical 2 by to get 1? Radical 2. And that's going to force the radius here to be 1 if I had a circle going around that triangle. What we're going to be doing is we're going to be filling in some points for all these angles that have a 45-degree reference angle. So we're going to come back to this in just a minute. And I can also think of this 45, 45, 90 triangle if I rationalize as being radical 2 over 2, radical 2 over 2, and 1. Everybody agree and understand where that came from? With the 30, 60, 90 triangle, I know the ratio goes 1, radical 3, and 2. But if I had a circle going around here, this hypotenuse would be the radius of that circle, and I want that radius to be 1. Again, a unit circle. So I would now divide every side by 2, and that would force my radius to be 1. Okay? So we're now going to use these triangles to take a look down here at what it says at the bottom with these values. If we're finding the sine of theta, and theta is 30 degrees, look back up at this triangle, the sine of 30 degrees. We do opposite over hypotenuse for now. What would that end up just being? 1/2. So the sine of 30 is just 1/2. But I want you to think of another way that we could do this. If I have a radius of 1, which is what we're doing, then wouldn't the sine of theta just be equal to whatever this y value is right here? Because I would do opposite over hypotenuse, but what are we saying the hypotenuse is always going to be? 1. So the sine of theta is now just going to be y. Okay, fill that in. The sine of theta is just going to be y. What's the cosine of theta going to be? Just x. This is a y, this is an x. So therefore the cosine would be the adjacent over the hypotenuse, but the hypotenuse is 1, so it's just going to be x. The tangent is always the opposite over the adjacent. So what's it going to be in terms of x and y? Y over x. Now, look at this point. Every point on the unit circle is x, y. What did we say is another name for x? Cosine theta. So a point on my circle can be thought of as cosine theta, comma, sine theta. Okay, that's a way we can think of every point on this circle. All right, let's go up here and get some points on the circle. Guys, the easiest ones to find are the ones that are quadrantal. Those are the ones that lie on the axes. So we have a unit circle. The radius is 1. So if the radius is 1, what is this point right here at 0 or 360? 1, comma, 0. Okay? Because we're going out 1 unit in the x direction. What about here at 90 degrees? What's this point going to be? 0, 1. What about over here? Here's the origin. We're moving to the left 1 unit, so we're going to be at good. And over here, for this point, we're moving left and right 0, but we're going down how far? So 0, -1. So we already have these 4 points figured out. Now, come down here and let's see how that helps us. We want another name for 0 and 360 in radians. Well, 0 is just 0. Do you remember what 360 is in radians? 2 pi. Now, the sine of theta is always just going to be what? X or Y? Y. So looking at the point at 0 or 2 pi or 0 or 360, what is the sign going to be right there? Is it 1 or 0? 0. So this is 0. The sine of 0 or 360 is 0. If I'm at 0, the cosine is going to be the x value. So the x value right there is just going to be 1. You should be writing this down. The tangent right there at 0 is going to be y over x. So 0. And then they want us to write it as an actual point. Well, we already have the point. It's just right there, 1, 0. Okay, so we just started with that one. Okay, we're going to go on down to 90 degrees now, because that's another quadrantal one. Let's do the point first this time. Our point is 0, 1. Let's fill that in. 0, 1. All right, what's another name for 90 degrees in radians? Emily, do you know radians for 90 degrees? It's pi over, what would I divide 180 by to get 90? Good, so it's pi over 2. Okay, now I want the sine right there. So the sine is just going to be what? The x or the y? The y. So Brendan, what's the y? So it's going to be 1. The cosine right there is going to be the x value, which is 0. The tangent is y over x. So what's the tangent of 90 degrees going to be? Undefined. 1 over 0. Okay, go to 180 now. Look at your point. Griffin, what's the point right there?
8.
Okay. And can you tell me another name for 180 in radian? Just
Pi.
pi, good. The sine of theta is going to be the y value. Frederick, what's it going to be? The sine of pi or the sine of 0, good. Okay, and then we know the cosine is going to be the x. And the tangent is y over x. So everyone, what's that going to be? Okay, and we're getting the hang of this, right? I can go quickly now. 270 is 0, -1. 270 in radians, though. Does anyone know that? Addie? Good. Because it's going to be 90 times 3. That's why it's 3 pi over 2. The sine is the y value. Cosine is the x value. Tangent is y over x undefined. Went through that kind of fast, and you can go back and look at that later if you need to. Okay, now we're going to go to this 30, 45, and 60. All right, these are a little more difficult. At 30 degrees, the x value, when I'm looking at 30 degrees, what is the x value here? It's radical 3 over 2. So that's what I'm going to fill in there, radical 3 over 2. The y value there would be the y value here. It's 1/2. So I'm going to go down and I'm going to put that point in on my chart here. So this is going to be the point, radical 3 over 2, comma, 1/2. Okay, what's another name for 30 degrees in radians? Ben Miller, do you know 30 degrees in radians? Pi over what? 6, okay. Okay, and then the cosine is going to be our x value there. Tangent is going to be y over x. Now this is challenging, but guys think. 1/2 divided by radical 3 over 2. 1/2 divided by radical 3 over 2. 1/2 times 2 over radical 3. So that's going to be 1 over radical 3. Can you think of what that would end up being? Good. Okay, so we got that all filled out. Okay, 45 degrees. Well, look at our 45 degrees. It's going to go x, y. Here's our x, radical 2 over 2, radical 2 over 2. There's our point. Okay, 45 degrees in radians. Millie, do you know 45 degrees in radians? Pi over 4. Pi over 4, right? Okay, the sine is going to be our y value there. Cosine is our x. Tangent, what's it going to be if I have something divided by itself? 1. Okay, 60 degrees. Okay, 60 degrees. Well, I really kind of need my triangle to go this way for 60 degrees. And I know across from the 30 is the 1/2, across from the 60 is the radical 3 over 2, and this is the 1. Bless you. So this is going to go 1/2 radical 3 over 2, right there. So that's going to be our point. Okay, 60 degrees in radians. Xavier, do you know pi? Nice. Sine is going to be our y value. Cosine is going to be our x value. Tangent is going to be this y divided by x. Can you guys think of what that would be? Radical 3 over 2 divided by 1/2 would just be just radical 3. Good work. Okay, guys, so this chart can be helpful for us. And look at some patterns. If we just go down to here, okay, if we just look at this part of it, you should be able to see some patterns. Look at this. 0 over 2, or even radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, even radical 4 over 2. You see what I mean? It's got that pattern there. Look at cosine. It goes from radical 4 over 2. Do you guys agree with me that radical 4 over 2 is 1? See that pattern there? Radical 4 over 2, radical 3 over 2, radical 2 over 2, radical 1 over 2. See, if we understand these patterns, it can make this easier. Our ultimate goal is to be able to fill out this whole unit circle, and it can help us to figure out the trig values. Now, personally, I can actually do trig faster by visualizing those triangles the way we did it last night on the homework. But there are some teachers who are very strict and expect you to be able to use this unit circle and write it down on your own. So I want you to understand how to do it both ways, okay? Let's go over to the actual unit circle, and I just want to see if you can come up with a couple of the points. I'm not going to take the time to fill this out with you because it's actually just too boring, honestly. It's too boring to sit here and watch somebody do it. But I want to point some things out that can help you. This is the piece of paper I gave you that looks like this. Okay, everybody with me on this one? Flip over to your actual paper. When I fill out the unit circle, I always like to do how we started with the quadrantals. I just think it makes it easier to figure it out if you start there. Okay, so let's do this real quick without looking back. Do you know what this point is? 1, 0. What must this point be then? Is it going to be 1/2 radical 3 over 2 or radical 3 over 2 1/2? Yep. Now, how is that helpful? Guys, everywhere I have a 30-degree reference, I'm going to have that same point, but the sign, positive, negative, might change. If I have 150, doesn't that also have a 30-degree reference? So this point over here has to be radical 3 over 2 1/2. But I have to check. Is this going to be positive or negative over here? X will be negative, won't it? But y will still be positive. Okay, let's do another one. 45 degrees. Can you think of what that point was? Can you remember it? Great. It's just patterns. And so this has to be radical 2 over 2. But which one would be negative, the x or the y? X. Okay, let's go down into this quadrant. I should be doing these at the same time. Which angle in the third quadrant has the same reference angle as 30 and 150? 210. So it's going to be the same value. Radical 3 over 2, 1/2. Check the signs. What's going to be positive or negative? Both are negative, aren't they? Okay, go to another one. What's another one with a 30-degree reference? 330. What's going to be negative there? Just the y, right? Okay, I should do all my 45s now. I got that, I got that. Here's another 45. Both negative. Okay, here's another 45. Just the y is going to be negative there. Okay? All right, is this making sense to you? You feel like you could fill this all in on your own? What about with the angles? Could you even do that? Let's do just 30s real quick together. What's 30 degrees? Pi over 6. Guys, everything that has a 30-degree reference, the angle has to be something times 30. What's 150? What times 30 is 150? Is it 5 times 30, 150? So this is 5 pi over 6. Here's the other one with the 30-degree reference. This has to be 30 times something. What is it? 30 times what is 210? 7. Okay, great. Here's another one with a 30-degree reference. It has to be something times 30. What is it? 11. Good job. See how all those with the 30-degree references have the pi over 6. Go to 45. We'll use a different color for 45. Anybody remember what 45 is? Pi over 4. Good work. So all these 45-degree references, we'll go back in a minute and see what they are, but they all have to be something with a pi over 4 in them, because that's our reference angle. Okay, 135. How many 45s are in 135? 3 of them, right? There we go. Don't you like this better than multiplying by pi over 180? I do. Okay, what about this one down here? How many 45s is that one? 5. Look at a pattern. 1 of them, 3 of them, 5 of them, 7. Okay? All right, so we are not going to take the time to fill this all out. I want you to do this later on your own, okay, using what we've talked about. You want to be careful to make sure this is right, because that's what we're going to use. Now, I want to show you real quick how we're going to actually apply this. So now let's go back to our notes online. And let's do some summarization here. Okay, actually, we'll do it down here. In quadrant 1, what's going to be true of all of our y values in quadrant 1? They're all going to be what? Positive or negative? Positive. What about in quadrant 2? What's true of all the y values? Positive. What about quadrant 3, all the y values? Negative. Quadrant 4. Okay, and you'll fill that out later. Remember, sine is y, cosine's x, tangent's y over x. And you can fill that in later too. But here's what I want us to get to. Examples, 9.4.2. How do we use this now? The sine of 120 degrees. This is how you did it last night, guys, how you figured this out. We would draw a triangle. We'd say 120 degrees is 60 degrees away. We'd go 1, radical 3, 2. We do opposite over hypotenuse. Everybody with me there? Well, now I can look at my unit circle. I can go to 120 degrees. And let's pretend we did this one. Of course, it's the only one we didn't do is this. But this point is 1/2 radical 3 over 2 with a negative on the x. See how, remember how we said it's just the y value there? Okay, look back again. The sine of 120, I go to 120, and what's the y value there? Radical 3 over 2. Okay? So if you can have that whole unit circle filled out, we can use this. Okay, let's go ahead and fill out 180. What's the point at 180? Negative 1, 0. Okay, so now we're going to here, the cosine of 180. Well, what's cosine? Is it our y or our x value? X. What's x right there? There you go. Okay, tangent of 330. Let's go to 330. 330, tangent. Remember, tangent is y over x. Quickly, can you think of what negative 1/2 divided by radical 3 over 2 would be? Are you guys understanding how we're getting that? Negative radical 3 over 3? Okay, because that's something I want you to be able to do more quickly. Okay, sine of 5 pi over 4. 5 pi over 4. What do I just look at for the sine? Is it the x or the y? The y value right there. Okay? You see how this can be helpful? Which do you like better, the triangles or just looking at this circle? Looking at the circle, you can choose which way you like better. All right, now watch, please. Come down here to number 7. This is something that's kind of been tripping people up. Find the measure of theta in degrees between 0 and 360. Sine theta has to be radical 2 over 2. Well, sine is y. So this is just asking us, where on the unit circle is y radical 2 over 2? Well, let's look. Y is radical 2 over 2 there, and y is radical 2 over 2 there. Why do I not have to look down here? Because the y's are negative. Okay, so our answers here would be 45 degrees and 135 degrees. Okay? Do this one on your own right now. Cosine theta, what is it? Equals negative radical 3 over 2. Just look at your circle. You should have it 150 degrees and 210 degrees. Did you get it? Okay, look at number 9. Tangent squared theta equals 1. Well, I have to get tangent by itself. So what do I have to do? Take the square root. I get tan theta equals plus or minus 1. Tangent is y over x. Now, listen carefully. Nowhere on the unit circle are you going to see y and x as 1 and 1. Okay, let's look. Y and x both have to be 1 and 1. Not there. Not there. Nowhere. But don't I get an answer of 1 anytime I divide something by itself? So what this is really saying is, where on the unit circle do we have something divided by itself where y and x are the same thing? Do you see anywhere that y and x are the same thing? And which quadrants am I going to use if it's plus or minus? All of them. All right, guys, I want to challenge you. I want to show you one more thing. Okay, here we go. I want to see if you can solve this. This is extra for experts. Let's see if we have any experts. So what if I gave you 2 cosine squared theta plus cosine theta minus 1 equals 0? And I want to know theta between 0 and 360 that would make this work. This says 2 cosine squared theta plus cosine theta minus 1 equals 0. And I'll give you a hint that you start like this. You have to think what times what gives you 2 cosine squared theta? What times what gives you 1? And the outers and inners have to give you a cosine theta. Take a minute and figure that out. I know you can do this. I'm going to give you a worksheet. Just
Yes. Yeah. Yeah, real. Oh. Here.
If you didn't know how to get started, here's the first step. That should have been your first step right there. Then you should have gotten it to this at some point. Did you guys get it to that step? Okay, who thinks they know all the answers? There should be 3 answers. Go ahead, Reed. What do you have?
20, 180. Go.
Anybody support that answer? No, they're not agreeing with you.
Wow.
I don't know. All right, let's go with you, Tulsi. Go ahead. 360, and then what? Okay, anybody have a different answer? We know you do. Do you guys, what is wrong with Reed's answer here? Sorry, what's wrong with it? Yep, because you were thinking if this was this cosine, if this was negative, then that would be those 2. But this is a positive 1/2. So we have to be in the first and the 4th quadrant. Did you just have a sign wrong in there?
I was listening.
Oh, don't listen to them. All right, guys.
So I can't get all 3,000.